Good afternoon, everyone. This is Karina from Hong Kong. My topic today is a comprehensive framework for evaluating blockchain-based system and body carbon management in construction industry. This is the today outline include the background, research method, development and design and development, and a little bit summary at the back. A little bit background is embodied carbon contributes significantly into the global carbon emission in the construction industry. The upfront embodied carbon defined as the emissions from material, transportation, and construction site activities in the construction project. COP26 call for net zero in all new building and existing building by 2050. IPCC bring out a important of carbon pricing as one of the mitigation measures. Therefore, carbon information sharing become very important. Then what happened in the market or industry? In the industry, we have a problem of poor carbon data sharing due to the massive carbon emission data in the whole construction supply chain. We try to leverage blockchain technology to solve the problem, but don't think blockchain is a complicated technology. So just think of it as a kind of database with immutability, transparency, traceability, privacy, and smart contract. But even though we try to use the blockchain technology, we still got some problem is in the current literature review is we do have a problem on how to ensure the traceability of carbon information sharing and the quantification process. The second problem is most of the literature review focus on computable matrix like the latency or the response time, but not focus on the comprehensive validation method. Therefore, the research question, the first one is, how can a blockchain-based carbon management system enhance traceability in information sharing and the quantification process of embodied carbon in the construction supply chain? The second question is, how can a comprehensive evaluation framework be developed to verify and validate a blockchain-based carbon management system? We consider the design science research as the research method. For the system design, we try to consider the key stakeholder in the construction supply chain, like developer, the consultant, contractor, and supplier. The system consists of the traditional centralized system, as well as the on-chain, the public blockchain platform as the database. In the off-chain level, that means the traditional system level, it's just used for the data input and the validation process through the smart contract for the carbon quantification and data recording. And it come out with the output parameter, which are immutable and transparent, as well as traceable that record in the on-chain. The parameter include the key carbon data, the hash value, the carbon emission at project level, as well as the company level. Once the data uploaded or updated, recorded on-chain is shared to the public. I try to explain how does the system work in a supply chain level. The architect just create the project or input the project and project team information, create the first bot, and supplier input the product emission factor, the quantity, through the smart contract, it come out with the total product and transport emission at that stage. And similar for the contractor to come out with the accumulated site emission data. And if I based on those data, the developer info and other smart contract to come out with the total project emissions. Because those you can see the bot are linked with unique hash value, so it can be very good or enhance the traceability. As I mentioned before, once those data are uploaded or record on chain, is share, open share or open accept by the public for the transparency. Just an example for easy understanding is architect create project, architect A, developer A inputting those project information. Supplier input the concrete emission factor, concrete quantity, contractor input the electricity emission factor and consumption. Finally, the developer have a total project emission. When someone asks you how does total project emission come from, we can answer the total product emission, transportation emission, or site emission, where they come from. If we very deep down to how did it come from to the product emission, we still can trace how much concrete they use or what are the emission factor. The whole supply chain, we can trace all the data. This is a little bit screen capture for the current prototype development. We have developed a prototype for the input process. And other screen capture is those extracted on-chain data. A little bit small, but we can, based on the smart contract, we can come up with the monthly consumption as well as the accumulated emission at each stage. Based on a ISO standard, we try to develop a evaluation framework for blockchain basis system. Verification and validation is a basic component under the evaluation framework. Verification is used to evaluate whether the system meet the desired objective, in which the prototype is tested in some real case study in terms of functional completeness or even the non-compliance condition. Another one is the validation, which used to evaluate whether the system can solve or address the identified problem and meet the user needs. The first one, we will validate the system performance, such as scalability, cost, but it varies, depends on the characteristic and nature of the system. The second one is usability. We carry out the survey with the testing party in terms of functional appropriateness, user experience, something like that, the certification. The third one is the system effectiveness. It's subject to specific enhancement feature of the system being tested, but we recommend to use a simulation or sensitivity analysis as a quantitative evaluation, surveys as a qualitative evaluation. Finally, is the industry impact, which included adoption challenges, short-term and long-term benefit and change due to the system. How can we apply to the previous blockchain basic carbon management system? As I mentioned, the proposed system included the off-chain part and on-chain part. We will try to verify the core system functions, such as whether the smart contract work or meet the design needs, as well as the functional enhancement feature. For example, this system is to enhance the traceability. We will verify whether it do achieve the desired objective. Because scalability used to be the concern for the blockchain, so scalability is one of the criteria for the system performance in this system. Cost estimation and latency also considered due to the stakeholder concern. Testing party to be involved in this in the usability testing include those who are involved in input and validation process, as well as those involved in the carbon quantification process. As mentioned previously, this blockchain-based system use a specific enhancement features for the data integrity, transparency, traceability, privacy. We'll test all the this kind of parameter in our validation framework. Finally, for the short-term impact, we try to identify whether there is a behavior change. For the long-term impact, we will consider or we will identify any adoption barrier. In summary, a off-chain traditional management system and a on-chain storage is developed to integrate together to form a blockchain-based carbon management system, as well as including the smart contract for carbon quantification and data recording. For the evaluation framework, apart from verification, we also included the validation covering the performance, efficiency, usability, system effectiveness, and industry impact. For the contribution, we believe that the study explore how a public blockchain-based carbon management system support the embodied carbon information sharing and quantification process, as well as introduce a comprehensive evaluation framework for the blockchain-based system. Thank you. This is the acknowledgement and then the key reference. Thank you.